How's everyone doing today? Fantastic. We today are going to be learning about how to name ionic compounds. Now, before we can name ionic compounds, ladies and gentlemen, we need to understand what an ionic compound is. An ionic compound is a compound that is made up of metals and non-metals, ladies and gentlemen. Now, the word ionic has the word ion in there. You guys probably remember that ion means charged. A charge would be like a positive or a negative. So an ionic compound is made up of charged particles, metals and non-metals. Now you can see metals make up the majority of the periodic table. Non-metals make up this little section over here, but we also have hydrogen. Notice hydrogen is blue and hydrogen is a non-metal. So that is metals and non-metals. We've gone over this before. Metals are always positively charged. These are always positive. All right, that's a big plus sign. These over here are always negative with a minus sign. The metals are called cations, a cation. And you can remember it's called a cation because there's a positive T right in the middle of the word cation. You can also remember cation because cations are positive, ladies and gentlemen, like a cat. Non-metals, it says always. That should not be there. But non-metals are negatively charged, and they're called anions. As far as you're concerned, they're always going to be negative. But in reality, they're not always going to be negative. But as far as we're concerned, these are going to be negatively charged. Okay, so those are ionic compounds. Again, an ionic compound is made up of a metal and a non-metal. All right, so let's take a quick look at their charges, because this is an important idea in this unit. So we've talked about the charges of ions before because we've had to build very rudimentary compounds. This is group 1 right here. Group 1. In group 1, every single element in there is going to be a +1 charge. So lithium is going to be a 1+ charge. Potassium is going to be a 1+ charge. Francium is going to be a 1+ charge. The second column, okay, here, I think I kind of wrote in the third column there, but the second column right here, ladies and gentlemen, all of these are going to have a +2 charge. Beryllium would be a +2, so I'd write beryllium like this, beryllium 2+. Calcium would be a 2+ charge. This third column, all of those are going to be 3 pluses. So it's going to be scandium with a 3+ charge. Yttrium with a 3+ charge. So the metals are always positive. Then we have these over here, the nonmetals. The last column here, called the noble gases, those noble gases have no charge on them. So these, you're not going to work with these because they don't react, but we'll just leave them there for 0. This fluorine column, these are always going to be -1. The oxygen columns, always going to be -2. Sulfur will be -2. Nitrogen is going to be -3. Phosphorus is a -3, and carbon would be a -4. So everyone all the way down is going to have that charge. So this goes 3, 2, 1, 0, -1, -2, and -4. So once we get into this zone here, these metals are called transitional. They are positively charged as well, but they don't have a +2, +3, or +1 charge. They have whatever charge they feel like having. Not whatever one, but for example, iron can be a 3+ charge, a 2+ charge, or a 6+ charge for iron. Copper can be a 2+ or a 1+ charge. Tungsten, gosh, there's like 5. Manganese, I think there's like 7 charges, a +3, +2, +4, 5, 6. So depending on what element we're talking about, these in here, we won't work with today. We're going to work with them next class because their charges vary. We're only going to be working with column 1, 2, and 3, and then these last columns. All right, so let's get going. Hopefully, everything makes sense so far. So as we're talking about these charges, I am going to provide you with, I've already provided you with, this little thing called the common ion sheet in their charges. So if you're going, let's see, what's the charge on bromine? I can't figure out, I don't remember what's the charge on bromine. Well, you come over to this chart over here on the side, and you look through it, and you go, okay, let's find bromine. Bromine. Oh, there it is right there. Bromine has a -1 charge. Now you notice the name has changed a little bit, but we're going to talk about that in a second. Maybe there's oxygen. You see oxygen, so go find oxygen. And you'll be like, oh, oxygen has a 2- charge. And sure enough, oxygen has a 2- charge. Phosphorus has a P3- charge, which is going to be called phosphide. So all of the answers are going to be on this sheet right here. And then if you're wondering about the positive charges, you can see on some of this, you can see chromium. They're not all listed because there's literally thousands of them, I'm sure. You can see that chromium can be a +2, a +3, a +6. You can just see the different options for it. But you have this paper to give you all the answers. So let's move on. So now what we're going to do is we're going to get into actual naming of these compounds. So what is the rules for naming? Before we can start, we have to work out a little bit of vocabulary. One very important vocabulary word is this word binary. Bi means two, like bicycle has 2 sickles or 2 wheels on them. So bi means 2. So we're going to have something called a binary compound. A binary compound means it has only 2 elements. So this one has an Na and a Cl. This is binary. I know you're going, wait, there's 3 here. There's a magnesium and 2 chlorides. No, it's the number of total elements. So this has 1 magnesium and a couple of chlorides, but it just has magnesium and chlorine in it. All right. This compound here, Fe2O3, is also binary because there are only 2 elements. Now, yes, there are 2 irons and 3 oxygens, but there's only 2 elements overall. And it says no more, no less. That's what binary means. Binary meaning 2 elements. Not binary, or also known as non-binary, I'll have it written both ways. Not binary means non-binary, means that there are more than 2 elements present in one ionic compound. Example of that, you can see that this element has a K, an S, and an O. And there are 3 elements present, which means it is not binary because there are not 2. Now, there's 2 potassiums, 4 oxygens, but again, we're talking total elements. This one, you have an iron, a phosphorus, and an oxygen. It is non-binary. This one has a sodium, a hydrogen, a carbon, and an oxygen. This one is also not binary. And you need to understand what that means so that we can practice our naming. Now, if you're looking at this going, I'll never be able to name that. Yes, you will. All you're going to have to do is cruise over here and look these things up and say like, oh, look, there's the compound I'm looking for. So this says HCO3 right here. You can see it says HCO3. You just got to go find HCO3, and we're going to call it hydrogen carbonate or bicarbonate. So again, it's not rocket science. You have all of the answers. Right? This is one of the easiest lessons that we teach each year where kids feel the most success. Okay, so all you have to do is follow the set of rules. Again, that's what binary means, 2 elements. Now, at this juncture, these are the rules. All right, we have a binary type 1, okay, and we have a binary type, non-binary type 2. Don't get crazy on that because there's only 4 types. This just means there's 2 elements, and this means that there are 3 or more elements. So we're going to get right into following directions with this flow chart. So first thing we have to realize is whether or not we're working with metals and nonmetals. So the first thing that you're going to have to be able to do you're going to have to be able to know the difference between a metal and a nonmetal. You're going to have to know that these guys over here are metals and these are nonmetals. An ionic compound is a mixture of these two types of elements. For example, the calcium is the metal, and the fluorine over here, that is the nonmetal. Okay, so you'd have the calcium metal and the fluorine nonmetal. It's got to be a mixture of red and blue. Yes, it's got to make purple. You'll see this next one here. This one is a mixture of metal. It's potassium with sulfur and oxygen. Notice metals mixed with nonmetals. If you don't understand that idea that we have the metals mixed with the nonmetals to make these compounds, you are going to struggle once we start learning new things. All right, that's what an ionic compound is, a metal mixed with a nonmetal. So first step you're going to do is you're going to look and you're going to say, is it a binary compound? If it is a binary compound, which means there are two elements only, you go to the yes side. If it's a non-binary, then you go to the no, it's not binary side. And then we get into these other instructions, which I'm going to take you through. So you can see that if you do go to the binary side, okay, then you'll take the name of the metal, which would be the name of the metal, and then you're going to take the name of the nonmetal and you're going to end it with this thing, this "ide." And I'm going to explain to you what that means right now. Okay, so these are all the nonmetals right here. Just this blue section, those are the nonmetals. The nonmetals are going to end with "ide." Name the metal, nonmetals, or the blue elements, end with "ide." I should have made that blue. So here's all the blue elements. I suggest you take some notes and write these down because you can have them forever. All right, put them on a cheat sheet. Now you do have them, and I'll show you where you have them in just a second. So you have them right here. So fluorine, we're going to replace the "ene" with an "ide." What, Mr. P? You're going to name the nonmetal and end it with "ide." So it's going to look like this. You're going to take fluorine, and that's going to turn into fluoride. Okay, so you're going to end it with fluoride. Chlorine is going to be named chloride. Good. Bromine is going to be named bromide. So when it's a negatively charged ion, that symbol "ide" means it's an F minus. So fluoride is F minus. Fluorine is just F. Chloride is F minus. Chlorine is just Cl. Oops, I should do that again, sorry. Chloride is Cl minus. Bromide is going to be Br minus. And we know it's a minus because this is the -1 column. Iodine or iodine is going to be known as iodide. All right. Now oxygen, which is right here, is an O, but if we're going to give it an O2 minus charge, it's going to be oxide. And the oxide is going to be written as O2 minus. That's what oxide is. Sulfur, a lot of people want to say sulfuride. It's not sulfuride, it's just sulfide. And sulfide, which is right here in the second column, is going to be an S2 minus charge as well. Nitrogen, if you want to put an "ide" on the end, some people say nitrogenide, which is incorrect. It's going to be called nitride, and nitride is going to be an N with a 3 minus charge because this is N. That's the 2 minuses. This would be the 3 minus column. Phosphorus is going to be a 3 minus charge as well. And phosphorus is going to be known as phosphide. And that's going to be a P3 minus. All right, P3 minus will be phosphide. Carbon is going to be known as carbide. And carbide is going to be a C with a 4 minus charge on it. As you can see, it's going to come all the way to 4 minus. This is something you have to learn. If you say sulfuride or oxygenide, I have to mark it wrong. Oxide is named oxide for a reason. Things like carbon dioxide or carbon monoxide. Iron oxide means there's oxygen in it and there's a charge. So all of these ides mean it's a charged particle. All right. So nonmetals end with ide. All right. Now, finally, 25 minutes into the lecture, let's get to naming ionic compounds. First, do we work with a metal and a nonmetal? Right? So there's a bunch of little things. Let me get that one right there. Okay, so the first thing we want to do, we want to say, are we working with an ionic compound? Well, let's take a look. Are we working with a metal and a nonmetal? Let's see, we're working with Na, which is a blue, not a blue, it's a red. That's a metal, and working with chloride. Good. Now, the metals always go first because they're on the left. And in English, we read from left to right. So it's going to be metal, nonmetal, sodium, and then the other thing. I'm telling you the answer by accident. So is it ionic? Yes, it is. Well, then we can use this. Is this binary? Are there only two? Yes. So we're going to come to the yes side. All right. So at this juncture, we've checked off, is it binary? Yes. Right? Yes. First thing we do is we name the metal. So what is the name of this metal? So I'll move this down so we can see. The Na is named sodium. Okay. Na is named sodium. And the Cl, all right, so let's name it. So we're going to name this one sodium. Sodium, that's the name of the metal. And then name the nonmetal and end with ide. So chlorine, end it with ide. It's going to be, oh, it gave me the answer. Sweet. Chloride, ladies and gentlemen. So this will be called sodium chloride. Let's take a look at the next one. All right. All right, so first thing we want to do, let's check to make sure that we are working with a metal and a nonmetal. Are we? Well, let's see. We are working with Ca. Oh, there's Ca right there. There's our metal. And are we working with a nonmetal? F. Yes, we're working with a nonmetal. So there's the calcium and the fluorine. So let's name this. Well, the first set of instructions say, is it binary? Yes, we're working with binary compound. All right? Binary meaning there's just two, a calcium and a fluorine. Check. Yes, binary. Name the metal. Now, I know you probably look down there and say, what does that mean? It means nothing until next class. Let's work with transitional. So the first thing we're going to do is we're going to name the metal. What's the metal? The metal is called calcium. The second set of instructions say, name the nonmetal, end with ide. Well, the F is going to be fluorine. But what are we going to do? We're going to end it with ide, so it's going to be calcium fluoride. Mr. Pepper, what are all these little numbers down here? You know what? That is a great question. It's showing that you're paying attention. Well, the numbers don't mean anything until next class as well. So this just means there's 2 scandiums and 3 oxygens, but we're not worried about that right now. So let's do the next example. All we're worried about is finding the total, the name, and yeah, let's see if I can move this over. I think I can. Let me move this up. Let me move this one down, shrink it down a little bit. There we go, that's better. All right, now we can kind of take a look. Oh, perfect. Now we can see everything. All right, so let's take a look. What are we working with? Well, we're working with an SC and an O. Let's find the SC. Oh, there's the SC right there, scandium. And let's find the oxygen. Perfect. Are we dealing with a red and a blue? Yes, we are. Perfect. So we're working with metals and nonmetals. Is it binary? Yep, there's just one scandium and one oxygen. Check. Name the metal. Okay, let's name the metal. Let's come on over. The metal's called scandium, scandium. And then we name the nonmetal, end it with ide. Oxygen is not oxygenide, it's called oxide. So this one's called scandium oxide. Let's do the last one. Mr. Peppick, it's just a pattern. Yeah, it's just a pattern. This is why kids do so well on this unit. All right. The next one, let's double check. Is it a metal with a nonmetal? Okay, yeah, sweet. We can use the chart. Is it binary? 1, 2. Yes, it's binary. So let's follow these rules. Let's name the metal, and then let's name the nonmetal. The metal is called potassium. Oh, there it is. Sweet, potassium. And the nitrogen is not, it's called nitrogen, nitrogen, but we call this nitride. And that would be the name, potassium nitride. If you have questions, redo it. I gave a lot of different examples here. So now let's move into, we just did the binary compounds with yes. Now we're going to move into binary compounds with no, ladies and gentlemen. All right, so let's get busy. So this one says, let's name the non-binary, but I'll take you through the whole process. Number one, are we working with metals and nonmetals? Okay, we've got a sodium, that's a metal. And we're working with nitrogen, that's a nonmetal. And an oxygen, nonmetal, sweet. We are working with not binary. So metals with nonmetals, check, but we're not binary because there's more than one. This one says, name the metal. So we're gonna go over there and name the metal. Let's name the metal. The metal is sodium, all right? And then we have to name this non-metal thing, but this one says, name the polyatomic ion. And that's, whoops, the wrong one. That's where we need to use this piece of paper here. Now, you were taught at the beginning of the year to memorize these polyatomic ions. We had tests, but it's been a while, we've forgotten. So we need to find this NO3. And if we look, it's right over here. And this NO3 is called nitrate. Our instructions clearly state, name the metal, I did that. Name the polyatomic ion. Poly meaning more than one, and atomic meaning an atom, so more than one atom. Yep, there's more than one atom, and it's a charged particle. Yep, it's charged NO3, so name it, nitrate. So sodium nitrate, N-I-T-R-A-T-E. That's the name. Well done. Let's try the next one. All right. Let's go to our chart. Mr. Peppick, do you have to do this every time? I do, because I'm teaching the class and you're learning, which means I'm going to follow the same system the whole time. So we have 4 more and then we're finished. Let's find them. Okay, we're working with calcium. There's calcium. We're working with an oxygen. Mr. Peppick, there's 2 of them. We don't care if there's 100. We just care that there's metals mixed with nonmetals. And, oh, there's a hydrogen. That one's blue as well. So it looks like these 2 kind of go together. So, is it a metal with a nonmetal? Check. Is it binary? Are there 2? Nope, there's not 2. It's not binary. No. Okay, so let's name the metal and then name the polyatomic ion. So first things first, let's name the metal. The metal's named calcium, calcium. Let's name the nonmetal, which is the polyatomic ion. Now, we said that the metals, we said the metals are positive and the nonmetals are negative. So these polyatomic ions are going to be negative. And if you see this chart over here, we can see that the front side, they're all positively charged things. And the back side, they're all negatively charged. I thought that was the best way to organize this sheet so the positives and negatives aren't all mixed together. So the ones at the beginning, calcium, let's see if it's here. Yep, there's calcium. Has a +2 charge, which we don't care about right now. All right, and then we want to find OH minus. Oh boy, let's see, OH. If I just knew that OH was called hydroxide, I'd be able to find it. Wow, there it is. And notice it's bolded because I use the same ones all the time. So we're just going to call this hydroxide. All right, calcium hydroxide. Let's name the next one. Mr. Pepe, you're going too fast. Rewind the video. That's what it's here for. All right, so here we go. Let's take a gander. Let's go through the process again. Is it a metal with a non-metal? Yes, it's a magnesium, and there's a phosphorus and an oxygen. Perfect. Is it binary? Nope, there's more than one. Name the metal, name the polyatomic ion. All right, let's do it. Mg is magnesium. All right, whoopsies. And then we got to go find PO4. Now, I'm just going to say it's negative because it's on the other. Magnesium's positive, so the PO4 must be negative. I'm going to hope that this starts with a P, and sure enough, there's my PO4. It's called phosphate. So this one's going to be called magnesium phosphate. Sweet. Mr. Pepe, I think I've got it. Yeah, I think I've got it too. All right, let's try the next one. We're working with an Na, a C, and an O. First thing we have to do, let's go find the Na. There it is. Let's go find the C. Perfect. And the O, awesome. Are we working with a metal and a non-metal? Yep. Check. Ionic compound. Is it binary? 1, 2, 3. Nope. All right. Name the metal. So let's do this. Name the metal. That one's called sodium. Sodium. Let's name this little this little carbonate, Whoops, I just named it for you. Let's name that little CO3. And there it is right there. There's carbonate, ladies and gentlemen, right? So CO3, it's got a little 2- charge on there, but it's not showing up here, but this is what we're working with, all right? So we'll go over there and write carbonate in. Let's see if it fills it in. Carbonate, sweet. Now this last one, all right, Mg, you know what, let's not put Mg, let's change that one because I used Mg already. So let's just find something else that would have a 2 charge. Another thing that might have a 2 charge. Anything in this column. So let's make that strontium. Okay, Sr. So I'm going to do that one right there. All right, so let's take a gander. All right, let's find it. We're working with an Sr. Where's our Sr? There's our Sr. We're working with a C, an H, and an O. First things first, ladies and gentlemen. Are we working with metals mixed with non-metals? Yes, we are. Sweet. All right. Check. Where's my palette? There's my palette. Check. Working with metals and non-metals. Is it binary? Well, let's take a look if it's binary. 1, 2, 3. No, it's got 4. Binaries are 2. All right. So, nope. So we're going to name the metal, and then we're going to name the polyatomic ion. So let's go to it. Right here, it's called strontium, strontium. And then we got to go find this polyatomic ion, poly meaning many, atomic meaning atom, ions meaning charged particle. And let's see if we can find it. We might as well just start at the top. Well, it starts with a C, so let's see. Oh no. No. Well, let's start at the beginning. Oh my God, it was the first one. How cray-cray. So this one's called acetate. So this one's going to be called strontium acetate. All right, and then we're done. So ladies and gentlemen, I highly suggest you either print this out so you have it right next to you, or you can have it accessible right here. But on your homework and stuff that I give you, I'm pasting it on your homework, so you'll have to scroll up to it. And let me show you what your homework's going to look like. This will be, this is your homework right here. So your homework is going to be, right? It says, write the name of the following ionic compounds. I will not use iodide. Why not? Well, because iodide looks like an L because I'm using the wrong font. But if you see a C with a little L next to it, I'm always going to be chlorine. All right? So what did we do first? We named the metal, magnesium. We named the non-metal, chlorine. End it with ide, chloride. Mr. Pepe, how about this one here? All right, let's do it. Name the metal. Lithium. Name the non-metal. Nitrogen. End it with ide, nitride. Boom. This activity should take you about maybe 7 minutes tops. And that's it, kids. Have yourselves an absolutely great day. If you have any questions, I'm sitting right here. Enjoy your day. All right. Oh, yeah. And if you are struggling, just go back and follow the steps. Right now, we are not using this transitional here. Okay. So where it says Roman numeral, we're not using that today. So there's no Roman numerals. We're not worrying about numbers. Those are out. But I have it there because next class we're going to be using it. All right. Good stuff. Have a great day, ladies and gentlemen. Good luck.